In the last video, we walked through how a single object level ACL entry can expose a file inside of a private GCP bucket to the entire public internet. No authentication required, no credentials, just a URL. This time we're going to do the exact same thing, but with Terraform. Same bucket, same documents, same misconfiguration, same fix. But now it's all in code. So let's go ahead and get started. With Terraform, everything you're going to see is reproducible. Anyone can clone the repo, run 2 commands, and have the exact same vulnerable environment standing in their own GCP project in just a few minutes. There's no manual steps, no guesswork, no console navigation. The infrastructure is portable, version controlled, and auditable, which also means that the misconfiguration will be too, and that's the point. So in a moment here, we're going to jump into the IDE. I'm using VS Code, and we're going to start to build this out. The first thing we're going to do is set up our backend state file. So stay tuned, we're going to go into the console next. Okay, now I'm in the IDE. I'm using VS Code to start building this project out. The first thing we're going to do is add a backend. We'll use a remote bucket to store our Terraform state file remotely. And we can do that using the CLI and just using a few gcloud commands. So I'm going to go ahead and paste in the command. We're going to create a bucket in the US Central 1 region. And I've gone ahead and added my project name as well as the name of the bucket. And we'll just go ahead and hit enter, and we'll wait a few moments while the backend state bucket builds. Okay, great. This bucket will store our Terraform state file remotely in GCP. It only needs to be created once and is completely separate from the demo infrastructure we're about to provision. Now, if we take a quick look in the console and we look at the cloud storage section, we can see that our demo bucket has been created in the proper region, and this is the name that we gave it. So we were able to create this object straight from the CLI. And now we're going to take a look at the main configuration file. Now notice that we have the Google Storage bucket established here at the top, and we have both the name and the location defined by variables. The key thing to note here is that the uniform bucket level access is set to false. That puts us in fine-grained mode, the vulnerable state. Everything else in this configuration depends on that one setting. And because we're using fine-grained access, we need to establish and define ACL resources for each object. Now if we go down to the next block, you can see here that we've established the document upload. We're referencing the PDFs from the docs folder. So if we look here, we have 2 PDFs located in the same directory, and we've established the content type as a PDF. Now the next section here establishes the ACL list for that document. This is where we assign permissions. We're using the Google Storage Object ACL and the setting role entity to owner. Now this means that only the scoped identity has access to this file. No one else, only one person. And that entity is established by another variable. If we go down to the next block, we have the same pattern as the secure document. We're referencing the other PDF from that same exact directory. Last but not least, we have the ACL for that object. The resource, however, has a completely different role. Instead of named user, it is set to reader:all users. So that's not a single person, that's everyone. Anyone on the internet with this particular URL will have access to be able to download this file. The overall bucket, however, is still private. Nothing else has changed, but this one ACL entry makes it completely vulnerable. Okay, so if you notice in this entire configuration, we never give the bucket a public access setting. From the outside, it appears to be private, but because we've set that ACL to all users on that specific document, all the information can potentially be exposed for our unsecured document. Okay, so next what we're going to do is run the configuration and watch the resources build in the console through the use of Terraform. Okay, now before we can deploy anything, we need to initialize Terraform. This does 2 things. It downloads the Google Provider plugin we declared in our provider file, and it connects to the remote state backend we just created. Without this step, Terraform has no provider to work with and no place to store the state file. You'll need to run this once per project or whenever the backend configuration changes. So we're going to go ahead and add that to the console. This will just take a few seconds. Okay, Terraform has been successfully initialized. Next, we're going to run a plan before we apply anything. This is just a dry run. It tells Terraform to read the configuration, compare it against the current state, and tell us exactly what it intends to build. So nothing's going to get created when you run Terraform plan, but you can see all of the resources listed. So I'm going to go ahead and add Terraform plan. And as you can see here, we plan to add 5 resources. If I scroll up a little bit further, you can see all of the resources that we're going to build, the bucket object, as well as the ACL permissions. And it also shows you the outputs that this configuration is going to create. Okay. Last but not least, we're going to go ahead and apply and use auto approve to provision all of the resources. Okay, everything has been applied, and as you can see here, all of the URL outputs have been generated in the console. So we're going to go ahead and go through each URL link in the next video. Okay, so as you can see from the output, we were able to obtain all of the necessary URLs to run our demo. If we want this output to look a little bit cleaner, we can simply run the clear command, and we can type in Terraform output, and in just a few moments we'll see that we have nothing on the screen here but the URLs. The first URL we're going to try out is the authenticated URL, and this is for the unsecured document. So when we access this URL, it'll open up in our authenticated browser, and it should allow us access to the document without any issue. So I'm going to go ahead and click on the link, and I'm going to hit open. And in just a few moments, the browser should open up. And as you can see, we can access the financial document without any issue. Again, this is expected behavior. The authenticated URL requires a Google login. As the project owner, I have access. Okay, the next link we're going to look at is the unsecured public URL. So if you notice here, that same exact document has a public URL, and what we're going to do here is copy it, and I'm going to open up an incognito instance of a separate browser. I want to make sure that I'm not using the same authenticated browser I used last time. I need to use a browser that is not logged into so I can replicate a public URL link. So if I put the link in the browser, perfect. So because this document is unsecured, the public URL is accessible to anyone. This is exactly the vulnerability we'd like to avoid. Any anonymous caller with no credentials can get access to sensitive information by using this URL. This shows you the danger of using the all users ACL entry. So I'm going to go ahead and close this one. Okay, the next link that we're going to try here is the secured authenticated URL. So for this one, we're going to intentionally use a authenticated browser. So I'm going to copy this link. I'm going to go right to my account. I'm already authenticated in this browser. I'm going to open up a new tab, and I'm going to paste in the link. And as you can see, I have access to the document without any issue at all. The authenticated link is operating as expected. The object ACL grants the named user, which is me, and I'm logged into my account, therefore I can access the document. Okay, we'll close this and go to the next one. Okay, the last link we're going to try is the secured public URL link. So in this instance, I'm actually going to copy the URL. Again, I'm going to open up a incognito browser instance. Again, we're making sure that I am not authenticated into this one because we want to simulate a public URL. And as you can see here, we've been denied access. So if you remember from our Terraform infrastructure, this particular resource did not have all users as the intended scope. Therefore, any anonymous users or non-authenticated users cannot access this document from the public URL link. So this behavior is accepted. All right, now I just want to point out a couple of pointers about the links that were created for our bucket objects. If I can refer you to the console, and if we look at the objects located in our bucket, and we just click one of them, you can see that for each object, GCP creates a public URL and an authenticated URL. Now, each of these URLs serve different purposes. Anyone who clicks the public URL can have access to view or download the file. Now, there's a use case for this. If you have a business that has publicly available website images or downloadable items or any open source files that you intend for the public to be able to access, then this is a legitimate use case to use this public URL. You also may have internal documents, company reports, sensitive information that only should be accessed by members of your company. In that case, you'd want to use an authenticated URL. Okay, now we're going to modify our Terraform code. First, we're going to flip uniform bucket level access to true. Since uniform bucket level access disables legacy ACLs, we'll need to comment those out. Then we're going to use Terraform state remove to untrack them. Then we'll save our changes. and we'll run Terraform apply auto approve. If we take a look at our bucket and we scroll down to access control, we see that it now says uniform. Our Terraform update is complete, and now we're going to check out the URL links. First, we're going to start off with the authenticated unsecured document first. Now, as you can see, we no longer have access to the document. So even though we entered a authenticated browser, because we enabled UBLA, we can no longer access the document. Now we're going to try the public URL. I'm going to open up another incognito browser. I'm going to paste in the public URL. And as you can see, we no longer have access to the document using the public URL like we did last time. The bucket now has uniform bucket level access applied, so even this public link is still not going to work, which means that our document has been secured. So before we switch to uniform bucket level access, that unsecured public URL link was working, and the document was freely accessible to anyone who had that link. No login was required, no credentials, nothing. But after one line change, we were able to block that path entirely. That's the power of uniform bucket level access. The object didn't change, the bucket never had public access enabled, but that one setting controls everything underneath it. Now, as I mentioned earlier, there's also another line of code that can be added if you wish to lock down the entire bucket, and that is the public access prevention mode. This serves as an outer layer. If you want to go a step further and enable this, you can. It's a simple addition to the same bucket resource, but it blocks all requests before they even reach the uniform bucket level access control. So I just wanted to show that as another possible solution or strategy to securing your documents in a GCP bucket.